He'll be here soon. Richie!
Another of the devices was a seismometer.
Have you cleaned your room yet?
I can't, Mom. I'm busy.
Was at the drill they had left during the
Busy? You know he'll be here any minute. Now clean your room.
But, Mom, I'm doing an experiment on chaos theory. Don't touch that.
Great prediction. Unknown at present. Let's do an experiment.
It's
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by the Do-It-Yourself Science Kit. Simple experiments you can do at home. New from DIY Sci.
Science is wonderful. It's in everything we see, feel, and touch. Science is how we learn about the world. With science, we found out that all of our food comes from plants. And plants make their own food from air, water, and sunlight. By watching clouds drift and ice melt, we discovered that matter exists in only 3 phases. We found out that dinosaurs once roamed the earth by looking closely at rocks. We learned that our sun is a star, just like all the other stars in the sky at night, by watching them rise and set every day. We watched shadows and figured out that our world is a spinning ball. We invented clocks. There are a lot of experiments that you can do at home to learn about huge scientific ideas. You don't need a special lab. Your lab can be anywhere, because science is something we do all the time, everywhere we go.
And then we'll go into spot bowling and picking up spares. Elizabeth?
I'd like to spend just a very few minutes reviewing.
Not only that, scientific principles hold true everywhere we go. That's right. A good science experiment is repeatable. Try this. Get a big bowl and fill it with ice water. Now, get a 2-liter pop bottle with its cap and fill this with very hot water. Ow, hot. Let the bottle sit for a few moments. Now dump the hot water out and put the cap on fast. I mean right now, lickety-split. And put the bottle in the icy cold bowl. Look, the bottle collapsed. Now why is that? Well, when you dump the water out, it's not filled with air. It's filled with an invisible gas, water vapor. And when you cool it, the water vapor turns to liquid water. Now, liquid water takes up hardly any room at all compared with water vapor. So the air in the atmosphere crushes the bottle like a giant's fist. Anyway, the atmosphere is big. So the effect is big. Come with me.
Warm air takes up more space. It expands. Cool air takes up less space. Cool air contracts.
Take a look at this. It's our great big atmospheric container crushing experiment of science. But now, instead of using a plastic bottle from the kitchen, we'll use this big metal drum. First, we lower it onto the heat.
Kids, this barrel thing can be dangerous, so stick to the pop bottle, okay?
Then we put in a little water. Now, we wait while the water boils and the steam drives all the air from inside the metal drum. That ought to do it. Now, we take it off the heat. And we seal it up with this. It's called a bung.
And that hole would be the...
Now all we gotta do is cool it off. Crushed it like a giant's fist. A good experiment is repeatable. It's science.
That's liquid air, boiling at a temperature of 190 degrees below 0 centigrade. Now, I know you're not used to seeing air as a liquid, but temperature and pressure determine the form and shape of most substances. You'll also see the effects that are obtained by using very cold liquid air.
Does air have pressure?
On objects that are not ordinarily associated with them.
Maybe there's an experiment we can do to find out.
You can see air pressure by using a clear glass of water, like this, and a piece of paper, a postcard, or a card like this. All you have to do is put the card over the glass of water, like this. Now flip it. The air pressure in the room pushes the card up against the rim and holds the water in the glass. All right, now we're gonna try it with something a little bit bigger. Fill it with water. Now we do the same experiment and put the card over the top, and it should work, right? Because it worked on the smaller one, and it's the same experiment. Well, we'll just do it. Dad?
Testing will sometimes show that you have not made the right guess. So you keep on thinking and testing.
May I be excused?
The lunar materials
Yes, you may.
were met with high excitement. More than 140 scientists in this country and
Mom,
beyond
what?
undertook painstaking and intensive investigation.
What's he doing here? He's showing us that you can do science anywhere.
You can?
Yes.
Yes, son. You can investigate huge ideas with common household items and a little ingenuity. Not only that, a good experiment is repeatable.
When matter is a gas, a lot of the time you can't see it. It's invisible. But here's a way to prove to yourself and any of our fellow scientists that invisible gas is matter. We'll weigh it. First, take a look at this broomstick balance of science. It's a broomstick with a hole in it. There's a lunch bag tacked to each end. Now we need to make some invisible gas. This is an old trick, but it's a good one. Pour some vinegar into a pitcher. Then add a little bit of baking soda. That fizzing is carbon dioxide gas coming off. It's the same gas that bubbles out of our soft drinks. Even though it's invisible, you can still pour it just like you pour water or milk. Pour the invisible gas into one of the bags. It pours even though you can't see it. The gas is heavier than the air and the bag on this end goes down. It's invisible, but it's matter. It's in the phase of matter that we scientists call gas. It's a gas! And it's total science.
Why all this emphasis on observing things? All science begins with observation. Because observation is one of the very best ways to learn.
Here's a light trick that doesn't need mirrors. Put a penny in a pie pan. Now move back so you don't see the penny. Don't move, because I'm going to pour the water in. It's okay if you make a mess. Pretty cool, eh? See, light's always bouncing off the penny. But when you pour the water in, it makes the light bend. And the bending of the light makes the penny reappear. But the penny didn't move through all of this. But don't take my word for it. Try it!
Son, I think it's time we had that talk about the birds and the bees.
Mom! Can I have a glass of water?
Yes, Richie.
That sounds tasty, honey. Can I have one too?
Why, of course, dear.
Air pressure holding up the card under the glass of water. Fascinating experiment you can do at home of science. See, the water in the glass doesn't spill out because the pressure of the atmosphere is pushing in all directions at once. So not only is it pushing down on the glass, it's pushing up on the card. And it's strong enough to hold it there.
Let's think about that.
This time, I'm gonna get some help. Cool. Okay, so now we put the card on top and flip it.
Exquisite.
Here's how you can make an egg tower. All you need is an egg and a couple of bottle caps.
Take an egg and put it between two bottle caps so that you have a flat surface. Then balance a book on top. Eggs are strong structures because the weight is spread out all over the eggshell.
This is an egg experiment you can try at home. Egg
Boy gives a brilliant performance on the track.
Building an egg structure with one egg was cool.
Insectopestins.
Right, with 3 eggs.
Take your eggs and place them between 2 bottle caps.
Arrange them in a triangle. Then set something heavy on top. Three eggs can hold more than 1 egg because the weight of the book and the soup cans is spread out over all 3 eggs.
Eggs, they're one of nature's most beautiful structures.
And that's no yolk.
Oh.
Eggs are strong structures.
I'll bet these eggs could even hold up cinder blocks.
Yeah, I bet you're right.
Set them down one at a time.
Eggs are amazing.
Richie? Richard?
See, that's the weight of the columns of air that press down upon the earth.
Dad!
And at higher levels, it causes correspondingly less and more.
Dad!
It might even take you 10 minutes to...
Richie, what is it?
Why do my clothes always get stuck together when I dry them? It's just not fair.
Here are 2 fun things you can do with your hair and a comb.
1. Cut a square paper. Tape it in a roll, like this. Then, comb your hair very fast. Hold the comb near the paper. Wow! Neato!
Am I having a bad hair day or what?
2. Comb your hair again. Now hold the comb near running water. The water bends.
Electrons went from your hair to the comb. All those extra electrons are what pulled the paper.
The comb built up a negative charge. That's what pulled the water molecules.
Static!
Well?
Richie, let me show you something.
Hey, let me try.
What Richie doesn't realize is that he and Dad have entered the static electricity zone. A zone where water molecules allow electrons to flow from one surface to another. In this case, the sock was negative. It had extra electrons. The shirt was positive. It had fewer electrons. The water molecules allowed the electrons to flow. They evened out. The charges neutralized. You know, this doesn't just happen in the static electricity zone. This happens all the time. I mean, you can repeat this experiment yourself.
Hey, Bill. It's science.
Let's try an experiment. Perhaps your mother will let you perform this experiment in her kitchen. All you'll need is a toy balloon and a tea kettle of boiling water.
Mom!
Here's an experiment that shows how the salty ocean makes things float better. A raw egg won't float in fresh water. But if you pour some salt water in a glass, it floats! It floats! It floats! That's because salt water has more stuff in it, so it can hold up the egg. Science rules.
We put the card over the top. And flip it.
Whoa, check it out, it worked.
Science is everywhere, in the trees and birds and the air. You can experiment with everything. Discovery's a lovely thing. Watch the clouds float by and think of water vapor in the sky. The water that you boil on the stove makes a cloud and then begins to roll. Do it yourself. Science with the stuff you find on the shelf. Science. If you experiment repeatedly and get the same results continually, then you know that your discovery has been achieved successfully. If you experiment attentively, you can make a great discovery. Say you want to make a snazzy boat, experiment to see what things will float. Do it yourself. Science with stuff you find on the shelf. Science.
Well, partners, that's our show. Thanks for watching. If you'll excuse me, I'm going to show myself some scientific principles with stuff I find around the house. Today, it's the angular momentum of flexible systems. See ya! It's repeatable.
Produced in association with the National Science Foundation.
First, what you do, palm up on the sides. Bring it across your body, palm down. Then you turn your palm over into back here. You know, lady, you've got a lot of hair. You want to look through the loop. That's what you want to do. You're a little close to me. I can't quite get the loop between you and me. Yeah, there, and let it happen. Yes! That's really good, man. You look at your target, you throw overhand, kind of like you throw a ball. Yes! Yes, yes. All right. 2, 3, go! That's not bad.
Okay. Ow!
It's a cut. Okay, good.